Okay, let's dive in. You've sent over a really fascinating stack of sources. We're talking everything from ancient philosophy to some pretty dense modern physics.
Right.
And the mission here seems pretty clear. Find the shortest path to understanding what might be the most radical challenge to, well, our entire picture of the universe.
That's exactly it. We are looking at a huge idea, contrasting these foundational concepts we all know, like atomism and the Big Bang, with a modern theory that just says no to all of them.
And that theory is called the theory of infinite hierarchical nesting of matter, or IHN for short.
IHN, yeah. And it claims to be a dominant scientific paradigm, one that could replace general relativity and the standard model.
Wow. Okay, so before we get to the, revolution, we have to start at the bottom, the absolute bottom, with the question that's bothered thinkers for millennia. What is matter actually made of?
Exactly. We have to start with this philosophical dilemma of the invisible atom. I mean, the concept of atomism itself is ancient. It goes back to Leucippus and Democritus, this idea, an ultimate hard, uncuttable particle.
But that idea didn't just sail through history, right? It fell out of favor.
For centuries, yeah. During the scholastic period, a lot of European thought was more focused on Aristotle's ideas, like minima naturalia.
Which is what, the smallest piece of something that's still itself?
Precisely. The smallest piece of, say, gold that is still gold. But even then, this logical flaw in the indivisible atom kept nagging at people. And it's what our sources call the elasticity paradox.
I think this is a fantastic way in. It really gets at the limits of classical thinking.
It's a deep philosophical trap. So, look, if you assume the atom is the ultimate, hard, fundamental unit, it has to be indivisible by definition.
Right.
But, and this is the key, if that atom interacts with anything, it's elastic, meaning it can bounce or vibrate or deform.
Then it has to have some kind of internal structure.
It implies a structure, yeah.
Wait, hang on. Why? I mean, if I throw a solid rubber ball against a wall, it bounces, it's elastic. But I don't automatically assume the rubber is infinitely divisible just from that.
But if that ball was truly fundamentally indivisible, a single unit with no parts, its elasticity would be impossible. If it flexes, that means one part of it moves relative to another part.
And if parts can move relative to each other?
You can logically draw a line between them.
So the very act of being elastic is an admission of divisibility.
It has to be. If it's elastic, it must be divisible. But if it's divisible, then it's not the ultimate fundamental atom we were looking for. It must be made of smaller particles.
And those smaller particles are either perfectly rigid, which means they can't interact with anything.
Or they're elastic, too.
Which means they're divisible, and we just keep going forever ad infinitum. That's a terrifying thought.
It is. And the consequence, which some of the philosophical texts we looked at really lay out, is that if you accept this infinite divisibility, matter just sort of dissolves. It becomes simple centers of force, not an objective, solid substance.
And the sources call this fatal to materialism. It breaks the whole idea that the world is built on solid physical chunks. You need a way to have this infinite structure without matter just becoming potential.
And that is exactly the problem that this theory of infinite hierarchical IHN claims it can solve. It offers a structured framework for this infinite divisibility, trying to give objectivity back to matter.
Okay, so let's unpack IHN. This isn't just a small adjustment to the standard model. It feels like they're rebuilding from the ground up. They even start with, what, changing the rules of logic?
Yes. The basis for IHN is something they call syncretic logic. Now, before you panic, it's not as scary as it sounds. Think of it like this. Physics usually runs on formal logic, A equals B. But when you're dealing with infinite structures,
you need a bigger toolbox.
A much bigger toolbox. So syncretic logic sort of gathers up formal logic, dialectical logic, which handles change and contradictions and other logic into one framework. It's a logic built for infinite complexity.
And the philosophy behind it.
It rests on the philosophy of carriers. The sources say carriers are the essence of the world. They're basically the components that allow for interactions to happen across all these different scale levels.
Okay, and that's where the nesting part comes in. The cosmos is organized like a set of, infinite Russian nesting dolls.
That's a perfect way to put it. You have your basic levels we know, like the atomic and the stellar planetary level, and then theoretically infinite levels in between, and smaller and larger.
And they're pretty clear that we can't see these other levels directly.
Not right now, no. Yeah. They say anything beyond elementary particles or outside our visible universe is only accessible through theory, through math. But the structure is there.
So how on earth do they connect those levels. I mean, the jump in scale from an electron's orbit to a planet's orbit is it's mind-boggling.
They bridge it with one really powerful core concept, similarity. They use what are called similarity coefficients and something called state symmetry.
Which is just a fancy way of saying the laws of physics are similar at different scales.
Exactly. This is the key thing you need to grasp. IHN treats the universe like a fractal. The laws that govern the micro level are highly analogous to the laws that govern the macro level.
So they put that into practice. They actually model the hydrogen atom, a proton and an electron, and compare it to a star and a planet.
They do. They calculate these very specific coefficients for mass, for radius, for velocity between those two systems.
And by using those numbers, they can take the quantum equations for the hydrogen atom and, apply them to a star system.
Precisely. And from that, they derive micro-level constants. They calculate a stellar Planck constant, for example, and a stellar Bohr radius, which is like the main orbital distance for their stellar version of hydrogen.
The point isn't the giant number they get, it's that the structure of the quantum world can predict the structure of the cosmic world.
That's it. The symmetry is predictive. And it goes inwards, too. Our sources say the theory suggests the internal structure of a neutron is fundamentally the same as a neutron star.
A stellar core is just a giant subatomic particle. That is a wild idea.
It connects everything.
Yeah.
And from this restructuring of matter, you get the theory's most provocative claims about the cosmos. We should probably start with gravity.
Right. Gravity, the domain of Newton and Einstein. How does IHN even begin to tackle gravity if it's already messing with space-time?
Well, it gives gravity a physical mechanism. It does this by reviving, and they claim, substantiating Lessage's theory of gravitation.
Lessage's theory,
Yeah.
that's the old 18th century idea, right? That gravity is a push, not a pull, caused by tiny particles bombarding everything from all directions.
The very same, sometimes called ultramundane corpuscles. And the idea is that two objects shield each other from some of that bombardment so they get pushed together.
Yeah, that's usually dismissed today, isn't it? As kind of a mechanical curiosity.
It is, because it has problems with things like energy and overheating. But IHN claims to make it work through the nested structure. They propose that fluxes of gravitons are what create dense objects like nucleons and neutron stars. And then those dense objects generate their own emissions, which become the gravitons for the next level up.
So it's a chain reaction. The emissions from the small stuff become the push force for the big stuff.
Exactly. And they also introduce a parallel idea. Strong gravitation. Now, this is not Einstein's gravity. This is a universal attractive force that acts at the particle level. It's the glue that binds nuclei, atoms, molecules.
So this strong gravitation replaces the strong nuclear force from the standard model.
In essence, yes. And they calculate it either by using those same scale similarity coefficients, or, this is fascinating, by just equating the strong gravitational force in their hydrogen model to the electrical force.
Suggesting electromagnetism and gravity are basically the same force, just at different scales.
That's the implication.
Okay, that's a huge claim. And to make all this work, they need new particles we've never seen, don't they?
They do. IHN predicts particles called preons and muons. And the muons are especially interesting for astrophysicists because they're proposed as the source of dark matter.
Wait, IHN solves dark matter.
It claims to. Their models suggest muons make up a huge chunk of the universe's mass, and they're concentrated exactly where we think dark matter is, in the outer parts of galaxies.
So IHN offers a solution for dark matter, and then it just rejects the biggest ideas of the 20th century. No Big Bang, you said.
No Big Bang and no black holes. The IHN universe is infinite. It has always existed. They also view quarks as quasi-particles, so not truly fundamental, and they see electron spin as a dynamical effect, not an inherent property.
This is a total rejection of the current paradigm. And they don't stop there, they even go after one of Einstein's core axioms.
That's right. They've developed something called the Extended Special Theory of Relativity, or ESTR. And ESTR directly challenges the constancy of the speed of light.
The famous C. They say it's not a physical law.
They call it more of a convention than an axiom with physical meaning. It suggests the speed of light might not be a universal speed limit, but maybe just a standard that's useful at our particular scale level.
That goes incredibly deep. It challenges how we even measure reality. But as revolutionary as this sounds, we have to remember that science has always been about these huge shifts. And often, the greatest scientists are the ones who resist them the most.
That's the crucial historical context. Absolutely. You see this pattern over and over. I mean, look at Einstein himself. He was instrumental in starting quantum theory. with his work on the photoelectric effect.
But he spent the rest of his life fighting against where quantum mechanics went.
Hated the probabilistic nature of it. He famously said God is not playing at dice because he just couldn't accept that reality wasn't, at its core, objective and predictable. He thought the theory had to be incomplete.
And at the same time, you have people like Paul Dirac, whose equation just, bam, predicts the positron, this whole new world of antimatter, and it explains quantum spin. He pushed the framework into really uncomfortable new territory.
Or Hermann Weyl, using abstract group theory to understand quantum mechanics, building this mathematical bridge between the classical and the quantum worlds.
But the resistance is just as powerful. I'm thinking of Arthur Eddington. Here's the man who confirmed general relativity in 1919. He made Einstein a global superstar.
A hero of science. Yet, decades later, when Subramanian Chandrasekhar did the math that predicted stellar collapse, that we now call black hole, Eddington just rejected.
He thought it was absurd.
Completely absurd. He couldn't stomach the idea of a singularity. He felt it was too non-physical to be real. He let his intuition, his belief in the existing paradigm, override a mathematical prediction.
And that's really the heart of it, isn't it? This idea of the scientific paradigm. An entrenched worldview, like the standard model or general relativity, feels so fundamental that it seems like reality itself.
It becomes opaque, and alternatives like IHN's denial of the Big Bang just feel completely counterintuitive at first.
Until the anomalies pile up. Things like dark matter or why gravity is so hard to quantize. You need that pressure to force a revolution. And IHN is presenting itself as the full-blown revolution.
It's a whole new map of reality, a reality where matter is infinitely nested, governed by similarity at every scale, and where the universe simply is. No beginning, no end.
So we've gone from a philosophical dilemma, the idea that infinite divisibility is fatal to materialism, to a modern theory that just completely embraces that infinite structure.
It takes the poison and turns it into the cure. It says the very nature of matter is this infinite nesting and scale relativity. The structure of everything depends on these relationships.
Which brings us all the way back around to the biggest philosophical question in physics. What is space and time? Is it container, or is it just a relationship?
Right, the debate between space-time absolutism, the idea that space and time are a real independent background, like a stage for the universe,
versus space-time relationism, which says that space and time are nothing more than the network of relationships between things. You take away all the objects, and space and time just disappear.
Exactly. So here's the thought to leave you with. If this theory of infinite hierarchical nesting of matter is right, if the entire structure of reality is defined by its recursive infinite relationships across scales, does that push us closer to one of those views? Does a relational theory of matter demand a relational theory of space-time?
It's a fascinating place where physics and pure metaphysics collide. Something to think about until our next deep dive.